Well, are you able to see the screen? Yeah. Like when I put it on the screen, I'm not able to see the chat. So can anyone talk up and like anyone speak and say that if it's able to be seen?
Yeah, we can see.
Perfect. Thank you, Johnson. Cool. As I told you, like this is going to be a beginner level blockchain workshop. Okay, like it's something that you don't need to know anything to start here. Like you come with nothing and you'll be able to learn blockchain right away. Start with blockchain. That's what we expect the outcome of this workshop to be. And as I told you, I work with Atinad Software, and I would take this opportunity to thank Prathidhwani and Atinad as well, which came in collaboration to present blockchain for you. Okay, now I would just start directly onto blockchain, but no need to worry. We'll go into deep and detail and see what exactly all these things are. The word itself, it says that a blockchain is something that chained, right? Some blocks are being chained, as you can see in the picture. So it's basically the continuously growing list of records, which is basically the block, which are linked and secured by means of cryptography. Okay, this cryptography kind of things might seem something very complicated to understand, but it's really easy. We will detail it one by one. So you have a block, and when the next block forms, it is some way, just understand that it is some way. Once again. Any questions, sir? Yeah. I just heard someone speaking, so I thought there was a question. Okay, fine. So it's a continuously growing list of records. A block has some kind of records. Just for the time being, just understand that a block has kind of records. And when the next block is formed, it is linked by means of cryptography. That's all that you want to understand from this slide. Okay. Now, going a little bit more detail, we call the first block as the Genesis block. Okay. Now, the Genesis block is normally the block that we blockchain engineers would be architecting, basically. So that's the initial block, and that's why it's called the Genesis block. The way how the blockchain works are usually set at this particular block. Like there are different parameters like target level and all, nothing to be complicated. Yeah. Good. Okay, fine. Noise, I think my motto, I think the noise is from my motto. Okay. Good. Okay, so we start with.
You can mute all. You can mute all for now. Otherwise, it will be very noisy.
Okay. Yeah, fine. So when you want to speak up, just unmute your mic and just speak it up. Okay? So for the time being, then as Smita said, if you could mute your mics, that would be great as well. Okay. Okay, fine. So what I was saying is that the initial block, which is called the block 0, which you can see at the left side is called the Genesis block. That's where normally how the blockchain should function should be told. Okay. Now, when it comes to block 1, it has a pointer, which is an hash, a pointer which is linked to block 0. This is where I said every block is linked by means of cryptography. Now, what exactly is the cryptography here is called the hash. Some of you might be knowing what a hash is. Like if you don't know what a hash is, I can straightly bring up an online SHA-256 basically. So SHA-256 is a family of actually you can use hashes. And, okay, so hash is nothing but I'll just show you. There are different types of hashes. So I'm just using the SHA-256. Just to give you a visualization of what exactly is meant by the hash. I think it's really taking time. Okay, let it just get loaded because we are coming to SHA-256 very soon. So at that point, okay, it's here. Okay, if I put an input, say for example, if I put 1, and I'll be able to see the output here. If I put hash, come on, this is seriously. Okay. It's supposed to give us an output here. I think it's something wrong with my internet connection, maybe. Well, no worries. We will come back to it. Okay. So what I was saying is that every block is basically linked by means of hashes. So when it comes to block 2, it's going to have the hash of block 1. When it comes to block 3, it is going to have a hash of block 2. And similarly, every n plus 1 block will have the hash of the nth block. So what happens is if someone comes and changes any data in it, the hash changes, and he will have to change the other block as well. So that's the beauty of how blockchain is secure. We'll explore it more, but for the time being, you understand every block is linked by means of a pointer, which is a hash linked to the previous block. Okay. Okay. Now, I just jumped onto blockchain, just told you about how a blockchain is and how it's being linked. Now, before we move on to blockchain, we really want to understand about the system between centralized and decentralized system. Okay. Now, a centralized system is something that you see in your office. For example, let me tell you, like in your office, you might be having a CEO, then under the CEO, you might have having a delivery head, then you have the project managers, and under that you might be having a technical lead, then you have developers. So when you look at the tree, that basically a centralized structure. So everyone is not capable of doing everything, right? So like an decision that has to be taken at an organization level will be taken by the executive body in the organization. So centralized systems are those that you have seen, like there is always a center point who will be acting, like the power is being designated at for different levels. That's how a centralized system. So that's where I use the example of an organization wherein there will be different levels of hierarchies. Okay, that's an example of a centralized system. And the reason why I'm saying centralized to decentralized, you will understand when we move on to the next slides, because blockchain really has a great application on moving a centralized system to a decentralized system. So when it basically comes to the decentralized system, as you see on the right side, it's not that a single person or certain designations are given certain roles. In a decentralized system, everyone has access. Like everyone is given what do you, it's better to say that you are democratically equal. Like no one is more than you, no one is less than you, everyone is equal. That's where the decentralized system comes. So imagine, like, me as in my organization, I got all the roles that I can do, which the other person also can do. There is nothing less that I can do than him. There is nothing more that he can do more than me. So that's where the centralized to decentralized is. Right now the world is so much centralized. So wherever you go, you look at the existing systems, you take examples of Facebook or Google. So like what happens is we live in a centralized world, right? Our data is being kept in centralized places by centralized bodies. Even everywhere it applies, you comes to healthcare, your data resides in the hospital, right? So you right now the world is so much centralized, and our target or the vision of blockchain is actually to make it decentralized. Now you might be asking yourself, how are we going to make it from centralized to decentralized? Yeah, Pradini has raised a hand. Anything?
Hello, now can you just make me host for a while, because I just want this to take to go live in FP page.
Sure, I'll do that. Thing I basically have to, not really. Come on. Not really. Yeah. Something here. It should be right. Like.
Move the mouse up to the top bottom, yeah.
Okay. Okay. Fine. No. This is about the slides, right?
Can you stop sharing and write?
Yeah. Okay. Let me do that. Fine. Okay. Once I stop sharing, I can see it here. Now. Ranish, I have made you the host now.
I think mine is just above that one. That is two Prathidhwani, right?
Okay, fine. So yeah. Oh, maybe the
Just
other
above that
Pradini.
one.
You can. Is it Smita, the other Pradini? I'll just ring up Smita.
And so that option is not coming for me. Can you just make me host? I think Smita is host now. Smita, can you make me host now? Hello.
Yes, Renish, I have just spoke to Smita. She will make you the host. Okay. I think Smita just want to switch the host to the other account, which Renish is on.
Yeah, I did that just now.
Okay, fine, fine. Renish, please let me know, once you're done. Okay, fine. So I'm back to host now. I'm going to share the screen. Cool. Fine. I believe you are able to see as well. So that's where we said, so sorry for the interruption, guys. So that's where we said right now what the whole idea was. Right now the world is more centralized, and what actually blockchain is trying to achieve is to bring in more decentralization. Okay, that's the whole point of the slide. Now let's before we dive into getting directly onto what blockchain and all, let us illustrate it by means of a simple example. Okay, so imagine your friend went for a tour like to another foreign country, and he ran out of the money, and he calls you up and says that, hey dude, I have run out of the money and please transfer me some money, right? So what you'll be doing is, right now you might be using your online banking. Previously you might be going to the bank, and you'll be basically giving him money. Like right now you'll be sending, you may using a UPI ID or Google Pay. You basically send money. So what happens on the background is, if you were going to the bank and remitting the money, is there is a teller in the bank who updates the ledger. The bank has a ledger and says that you have transferred your friend Joe $1,000. Okay, this is being right now done on the records. That's a person who is going to update it, right? When this updation is done, obviously Joe's account is going to get credited with $1,000 because the person has updated it as $1,000. That's right now what's going to happen. Okay, now just tell him that, okay, I've sent the money. He just thanks you, is so happy. Okay, now what is the real problem with this particular system? You rely on bank. Okay, there's always a center point of failure. Okay, let's see how it is. Okay, now if imagine like right now it's all digital records. And if, let us assume for the sake of argument that it was a bank where it was written in books as previously. And let me just ask you by the question that, okay, what if the registering transaction was burned, like the ledger was burned? Possibility. Now, instead of writing $1,000, if the account manager or the bank teller who updated by mistake wrote $1500, like 1500, there is a chance of failure, right? He can mistype it. Even if you said you wanted to transfer $1,000, which cannot right now be happening with an existing digital banking, but in the previous scenario, it could have happened that he could have rightly said. And there's also a chance, since you bring a centralized party, right? You are bringing in a middleman. What if they did it on purpose? Like you wanted to send $1,000, instead they wrote that $10,000 was sent. That there is a chance that, right? So there are chances of why such kind of chances come. It's because you rely on a middle party. You rely on a centralized person to do your thing, right? So centralization is always a dependency. This happens everywhere. Wherever you go, you rely on a middleman to do your things, right? So this is how the world right now works. And this is where actually blockchain comes in. So you may have the question that, okay, right now the transactions cannot be burned. You're true, right? With the digital banking that has emerged, with the digital records, it cannot be burned. But what if an admin who has access to the present system, all the bank has its data being stored in the cloud or their particular systems, right? And every systems right now comes with an admin access. Now, admin is a person who can log into the system and manipulate the records. He can directly make it, right. That's possible. And with the present money, like if you're from India, an instance where the government came directly and told you that from tomorrow your particular currencies of 500 or dollar, like 1,000 rupees is 500 is not valid, right? He came like he said 1,000 rupees is not valid, right? Why did this happen? Because you rely on a central party. You rely on someone whom you trust upon. But the chance of the person whom you trust, because you have given the rights, he acts on behalf of you. When you hold a 1,000 rupees Indian rupees currency note, it's clearly said that a promise is given, right? If you have read the note, it said that a promise is given to the bearer. Now they can say tomorrow that this promise is no more valid. We have seen what happened. This all happened because we live in a centralized system. Okay. Now, what is the solution to it? Like, how can we think about a solution to it? So I would like to illustrate with the same example of sending a money. But instead of that, I would like to bring in a set of people who want to participate in the system and remove the intermediary bank from the picture. Okay. I'm not having a centralized person in picture, centralized bank in picture, but instead, all of us, let us imagine that all the participants in the meeting has come across and we all sit around the table. Okay, just for the sake of argument, let's assume that we all sit around the table. Let's take that 10 people are here. Okay, now everyone sits with a blank page and a pen. Okay, everyone has a page and a pen, and everyone is ready to write any transaction that occurs within the system. It's a public system, like everyone knows who has what. Everyone sits with a pen and paper, and it's being announced. So at this particular point, the second person, as you see on the picture, wants to send $10 to the ninth person. Okay, now when he or she want to send the $10 to the ninth person, she shouts and tells everyone, like she shouts and says that, okay, I am going to send this $10 to the ninth person. She shouts such that everyone can hear it. Okay, so person 1 to 10 is able to hear when she says that she want to transfer $10 to the ninth person. Now, since it's a public system, everyone knows, right? So you are making a transaction which everyone knows. So everyone knows what my present balance is. Like everyone's balance is known to everyone. So everyone checks. The initial check to be done is whether the second person has enough balance to transfer this $10 to the ninth person. Okay. So she shouted and told. The next thing the other people are going to do is to check whether the person has enough balance. Okay, now if she has the right balance, if she has a balance more than or equal to what she has to send, they're going to write it. They're going to make a note of transaction on their blank pages. So I told you there is a blank page with everyone, with every 10 participants, and they write it on with a pen that they're going to make the transaction. Okay, so as you see on the blank page, they write with the date and time. The second person, the 9% sends $10. That's the first transaction. Now let us assume that everyone starts sending like this. The third person says to the fourth person that he wants to send $5, and other people, like everyone starts to do it. What do? We basically check whether the person has enough balance, and if he has the balance, we are going to write more transactions. So you start with the first transaction and you write the second transaction and you go down, down, down. Now what happens? You write it on a piece of paper, right? Now the paper is full. You want to keep the paper and bring a new paper, right? So the example that I'm illustrating right now is analogous to how blockchain works, and specific terms in blockchain are placed here. So I just wanted to tell you, right, a jargon box term. This is called mining. Nothing to keep complicated. Just imagine that this is mining. We'll come back to and see how really mining works. So right now, everyone started writing the transaction, and when the page is full, like when it reaches the end, we are supposed to take the next page. So we need to put the page in a folder and bring a new page. Okay, we're clear with that, right? Okay, so now putting away the page. Now putting away the page is a crucial thing that previously when I told you a block has a hash, this is where we bring in the concept of hash. So that's the place where we have to seal it. A unique key must be present that everyone has to agree, right? The page that I am keeping should be the same as everyone in the network is keeping, right? Because we all write the same transactions. So we have to agree on, like, even if tomorrow if someone comes and checks the page, the same page must be available across all the participants in the network. Okay, we call this as a network. Now, by sealing it, what do we say? That once we seal it, we ensure that no one can come and make any changes to the transactions on the page. Okay, once we seal it, how is the seal important? Like no one can come and change any transaction. Okay, so that's the importance of sealing. Now, this is where we bring in the magic function. Okay, the hash function is actually the magic function. Okay, I would previously take the hash basically just to give, if someone who doesn't know what actually hash is, whatever input you give, like I'm giving an input here, you get an output here. Okay, see, for the one, our output is unique. Whenever I type 1, it's going to be the same. But if I make a single change, if I just add a letter 2, the hash completely changes. Hash is a fixed output length thing. Okay, so SHA-256 is the hash that I'm using here. So whenever I put an input, I get a fixed output. So I would like to call it as a magic function here. Okay, now so to put away the page, I bring in a magic function. This is a hash function basically. So when I input 4, the output that I get is constant anytime, anywhere. You put an input, you get a constant output. That's the hashing function. So the magic machine is our hashing function. So hash of 4 is always equal to DCBA. I'm just taking an example. Okay. Now what we basically do is, we are given an input, we can easily find an output. If I'm going to tell you, I need an output, I give a fixed output and ask you to bring an input. This is actually the core concept of blockchain. In a hash function, you give an input, you get an output. What if someone gives you an output and asks you to bring an input? It's not at all easy, right? The previous example of the browser, whatever you saw in the browser, you put an input and you got an output. Now, if someone gave you the output, how do you predict the input? The only way is to brute force different combinations, right? You'll have to start from 0, say for example. What you're going to be doing is you try different examples or you try different inputs. For different input, you start getting different outputs. Okay, so at particular point, like you start doing it, you brute force your machine tries on calculating to find out an input such that it matches the output. Now the output that I have particularly in mind is an output that must start with 3 zeros. Okay, then at some point a person from the network says, I have got the input. He says that you got an input like 72533, which actually gives an output 000CA, which basically satisfies my condition that an output should start with 3 zeros. Now, different people have different computation powers. All the people who sit in the network, we imagine it to be taking place over a table, but actually they are doing it by means of a machine, a computer, a node. And whoever has a better computation ability comes up with the input first, right? So this is the beauty of blockchain, right? The hash function, it's not the beauty of blockchain precisely, it's the beauty of hash function. Whenever you get an input, it's easy to verify. So given an output, it's extremely difficult to calculate an input, but given the input and output, it's easy to verify. Okay, now, as I told you, we need to keep the seal, we need to keep the page. Now, how do we find the page? Imagine like I have an input already 20893, which is the hash of the block. Now, a block is a block or a page is equivalent to a block. Okay, now on a page, we had certain transactions happening. Now, when we have all the transactions summed up, we take a hash, we get a value, say for example, 20893. Then the condition is find out an addition value when added to this particular number should give an output which starts with 3 zeros. So previous example was directly saying about an hash function. In our case, we have an input, a block hash with some value has to be added to it such that a particular condition has to be satisfied. What has to be done? Similarly, like what we did before, the only thing is brute force your machine, try about several combination, and finally you comes up with a number called 21191. Just an example. Okay, so when this two gets added, this particular, like the value is 42,084, the hash function basically yields starting with 3 zeros. That's the difficulty condition. Now, where is this difficulty condition set? It is in the Genesis block. Nothing to confuse. That's where difficulty condition rises. Okay. Now, the whole point is you brute force your machine to output to get the particular number. And for the value of 20893, 21191 is your ceiling number. Okay. That's basically the ceiling number, the seal number to be set there. Now, when the second person was sending an amount to the 9th person and there were different such transactions and a particular page was formed, to keep it away, everyone starts calculating the particular ceiling number. And fortunately, the 5th person at first comes and says, my ceiling number is, or the ceiling number that satisfies the condition is 912574. When the first person who gets the number announces it, what the rest people of in the network does is they just stop the whole process. For them, they just need to verify. We know that if the input is given, it's just a matter of passing it through the hash function and seeing whether it is valid, right? So verification is really easy, but computation is really difficult. That's the whole beauty of blockchain. So if someone says that this is a particular number which has to be added to the block hash to get the particular output, it's easy to verify. Everyone starts verification. And whatever the majority agrees upon becomes the honest ceiling number. Now, there may be instances that the person really did not write the transaction in the right order, or he missed some transaction and he came up with a ceiling number. But the people will not agree to it. Why? Because when they tried the initial, if you would remember, in that case, the previous value 20893 or the hash of that block will not be the same for the others. And hence this will not be valid to satisfy this. Okay. So that's where when the person says a ceiling number, if everyone checks it with the hash function, whatever the majority agrees on, it's said the 51% rule, whatever the majority in the network agrees on, it becomes a honest ceiling number. Now, you may ask that, why do everyone want to compute? Like, why not wait for someone to announce? That's also possible. Like when I explain the Bitcoin blockchain, I can tell you the nodes can be miners or they can be just clients. Okay. But why do people want to participate in this particular process called sealing or mining? Because whoever participates in that gets some incentives which comes by air. Okay. Say for example, when I was sending in real use case, the second person who was sending $2 to the 9th person, they may not be just sending $2. They might be actually sending a little more than 2, like 2.1 or 2.2. That's an extra incentive. Along with that, the blockchain network also gives an incentive for the mining. So new coins or new values comes out of thin air whenever a new block is added. Okay, this is particular to a particular blockchain called Bitcoin, but I'll detail it. Okay, so everyone who want to make the reward, who want to get this reward, become a participant of the mining group, like they run their node and makes the computation. So now if I'm going to sum it up, single page is a block of transaction and the folder is a chain of pages. Therefore, a folder turns into a blockchain. This is how actually the Bitcoin came into existence. Like, is there any doubt from any one of you at this point?
Yes. No,
Yes,
sir.
please. Yeah.
Yeah, I'm Jacob here. Yeah, you said about the input and output. So
Yeah.
who decides on this output? Like this should be the output. Like is it from the network or
Like
system?
initially when I was telling you, whenever a blockchain starts, it starts with a particular block zero, Genesis block. Okay. Now the blockchain engineers or the blockchain creators would write a difficulty level in this particular block. Now this difficulty level is supposed to propagate along the blocks. As the blocks move on, the difficulty level is said to be increased if the engineer has decided the difficulty level should increase. Now, if I'm a blockchain engineer, I can say that if I create my initial block, I can set the difficulty level to be 0. Like, so this condition of satisfying a particular output is defined in this particular block 0, which is called the Genesis block.
Okay, and this block is then given to the group of people who are in the network.
Exactly.
To make
Everyone
the
starts the block with this Genesis block.
okay, to record the transaction they'll use. So this is the page we'll get from the Genesis block.
Yes. Now imagine if a new member comes onto the blockchain. If he want to join with the block, he needs this Genesis block.
Okay. So
It's
is
a
it
matter
like
of
that you
syncing
need
up.
to is it need to buy it or
No, it's just a simple file. Like, it's a file that you just want to have a copy of.
okay.
Okay. Any more questions? Why I have stopped at this particular point is this is actually the root concept that you need to clear at this point as we move on. So this is like all the example that I have illustrated right now is sending money from one person to other. Now we have replaced bank. We have, instead of bank, the technology is taking care of the bank here. So I'm not sure like anyone of you have used Bitcoin or cryptocurrencies with you. So the whole beauty is that you don't rely on sender persons. Like tomorrow there is no one who can come and who will come and say that, okay, from tomorrow this particular currency is not valid. Like this is all secured by means of technology. So this is the whole concept of how blockchain came into existence. Okay, like
but ultimately we need to reach bank for them we need to convert these bitcoins, right?
yeah, that's exactly. It's not really required to be banks. You might have heard the concept called exchanges, where you can convert your fiat currency into cryptos.
Yeah.
Yeah, so exchanges provide the interface where you can actually convert this.
Okay.
Okay. So with that, I'll move on now. So the longest chain is the true chain. Now, why do we say the longest chain is a true chain? I told you the condition when the particular person announced the ceiling number. Now, imagine two persons came up at the same time and announced the number, right? We have just illustrated the scenario just being a 10 members around a table. In fact, the real network is so huge, like, the nodes that are visible to your region, like if right now I have my Bitcoin node running from India, the nodes that are more closer to me will be the one from China, Pakistan, Afghanistan, and nearby nodes, right? And someone from US might have at the same time announced the mining, right? Someone would have said that, okay, I have got the ceiling number. Now there are chances that a chain can go in two different ways. Okay, this is basically a concept called forking. Okay, this is soft fork. This is something that happened. There are two types of forking, like hard fork and soft fork. Fork is something that by network, when there comes a confusion, there starts two chain. Okay, now, but even though there starts new chain and it goes on propagating, at some point of time they realize that This is not the true chain anymore because there is a chain which has already exceeded in number. So that's where the concept called the longest chain comes. Imagine it was block one, and at block one, it actually changed to the other block and it reached at this place where it is like for this, it is block four. In fact, they realize for the particular blockchain, a block six already exists. Then what they do is from the place where they have gone into a disagreement, they remove all these blocks. Like they consider this as invalid blocks and they switch directly to the longest chain. So the longest chain is the true chain. That's exactly what is existing. That's why there are particular points where such kind of soft forks can happen. And this also has implementations. Say, for example, there came a DAO attack. There, you might have heard about attacks that happen in the crypto domain, basically. Now, when a DAO attack has came in, the person has stolen a lot of money, and they wanted actually to reverse the transaction. So the community came into an agreement, basically saying that okay, if the attack happened at this particular block, like if the attack happened at a particular block, let us all revert to that transaction. That's where the majority has to agree, and majority has to agree to a new chain. That's called hard fork. It is something that you may find right now it's little difficult to digest, but as we move on, once you understand blockchain and you read further on soft forks and hard forks, you'll be very clear on that. So essentially, it's all about a fork can happen by network with some confusions can arise, and it can also happen by choice of the community. When more than 51% agrees to it, they can decide on a particular block. Okay. Till now, I was telling you about sending in money. That's where actually this particular concept called Bitcoin came into existence. Now, blockchain was not invented first. Bitcoin came into existence, and the underlying technology of Bitcoin was actually called blockchain. It was not blockchain which came into picture first. It was actually the Bitcoin. And the Bitcoin is a really interesting story. Most of you might be knowing. It was invented by a mysterious person called Satoshi Nakamoto. The reason why he remained mysterious is because he did not want this technology to be owned by someone. Like, this is speaking all about democracy. This is speaking all about giving equal power to everyone. And what I truly believe is he basically did not want a particular honor for this technology, because every time when the technology has to go through certain changes, everyone will be referring back to Satoshi Nakamoto's Bitcoin, right? So Satoshi is a mysterious person. We never know whether it's a person or it's a group of developers, right? Yeah. So basically, you have an address on Bitcoin. So previously, when I told you second person was sending to the ninth person, like we take the example of Alice and Bob. So Alice has a particular address and Bob has a different address. Now, when Alice want to buy something from the Bob, imagine it's in a supermarket store, she she want to send, like, the transaction here is sent, say for example, 2 Bitcoin to Bob. She want to sign it by means of a private key. Now, where does this private key come in? So that's where a concept that I have not explained till now. There is a wallet always associated with the person. It's basically the cryptography. Like, there is a public key. So whatever you see is an illustration of the public key here. So public key is something that you can share, but on your wallet, secured by means of a password, you have an encrypted private key stored. Now, this can be a mobile wallet. This can be an hard wallet and soft wallet, like something that you can keep on your browsers, and something that you can print and keep yourself and only present while making transactions. So there are different types of wallet. So just for the time moment, just understand, wallet is somewhere where you have your private key securely in encrypted form stored, and it is encrypted by means of your password. For the simplicity, just understand that the private key is encrypted by means of a password. Now, when Alice want to send the particular Bitcoin to Bob, the message which is basically sending is signed by means of Alice's private key. Now, it reaches the blockchain and it is added as a block. Now, as we saw before, it is broadcasted to the mining nodes in the Bitcoin network. And when the particular block containing the transaction of Alice, it's not just the Alice transaction that's happening. There will be a couple of other transactions as well in that particular block. It gets the network of node validates the transaction using the algorithm called mining. Now, the algorithm that we here use is called POW. It's called proof of work. Why it is proof of work? Because essentially there is a lot of computations being done, and that's why the name is proof of work. Like, there is a brute forcing of finding out the input, right? So among the consensus mechanism, like why do we need a consensus actually? Like imagine if it was just between two or three of us, we could have just said that, okay, I have made the transaction, I can email you, right? I can email you, I can phone you, I can SMS you, we all can come into an agreement. But when it's such a huge network, you wanted to come into an agreement by means of technology. So consensus is something that by a mechanism by which everyone comes into an agreement that, okay, this is valid. So in case of Bitcoin, the particular consensus algorithm is called proof of work because there is a computation which is involved in order to mine the block or in order to add the block. Okay, so the first miner validates the new block and gets the reward as well. When the transaction is complete, the block is added onto the blockchain and it is permanent and cannot be modified. So this is the beauty of blockchain. As I told you, there is a ceiling number, something that gets confirmed. It's something immutable, like tomorrow no one can come and change the data. That's secured by means of blockchain. So right now, when I speak to you at this particular moment, the technology is such that we have been speaking about supercomputing or nanocomputing, those kind of computing that can evolve. So tomorrow, we are not sure about if such, like right now with the present systems, they are not able to break the particular blockchain security. But tomorrow, if something like that is going to evolve, for sure, we as a community ourselves see that blockchain is also going to evolve along with it. So right now, there's no technology that can actually really break it. But uh, when I say that that cannot be really broken, there are certain conditions which can be used. But I don't want to bring such complications right now. So what you just want to understand is the records or the transactions that you want or you make on a blockchain, on a Bitcoin blockchain sending is immutable. Even if one person hosts a node and all others go, the records are valid. It's available. Okay. So that's about the Bitcoin. So that's the story of Satoshi. Like there is no ownership, that's the technology here. And with Bitcoin, like the underlying technology is blockchain. And that's where I would say the evolution of blockchain happened. So initially Bitcoin was just, as you can see on the picture, it's a public blockchain. Like everyone can see who all has balances. But when I say who all has balances, me, you, or anyone on the Bitcoin is just a address like this. So it doesn't know that this particular person is Mama Naushad. So, but there are chances of correlating. When I say chances of correlating, when me, Alice, sends this particular amount to Bob, I know that this is Bob. Now, when I search for this particular address transaction, since it's a public blockchain, I can see what what Bob already owns or what is the present balance of Bob. So there is a correlation chances that can happen here, but it's advisable that you keep rotating your public address. Keep rotating means you create new account. You can also, if you have this particular account and tomorrow you create another address, you can transfer your Bitcoin to that address. So the less the chances of correlation. There are other mechanisms as well, but I don't wish to complicate here in order to hide those details. So it's a public blockchain. Everyone knows who has what, and there is an innate cryptocurrency here called the Bitcoin. It's a distributed ledger as well. Now after Bitcoin, there came the Ethereum. Ethereum was actually invented, or it's right to say that it came into picture by a guy called Vitalik Buterin. So the added functionality to the existing Bitcoin was he came with the concept of smart contract. We'll explain smart contract in detail. And in Bitcoin, the cryptocurrency was Bitcoin itself. And when it comes to Ethereum, the native cryptocurrency is Ether. Along with that, with the use of smart contract, you are free to architect or you are free to create tokens on top of Ethereum. Okay, so there is a native cryptocurrency called Ether. Along with that, you are free to create tokens on top of Ethereum blockchain. It's again a public blockchain and all the transactions are public. And the consensus mechanism that they use in Ethereum is also proof of work, basically computationally intensive one. So then that's about Bitcoin and Ethereum. So you might, some of you might be knowing that since knowing the incentives of what can be obtained with Bitcoin, there were a lot of mining farms being set up, particularly in China, particularly in areas where the electricity is low. Like, you need a computationally intensive process. That's where GPUs were extensively used in order to do the mining. So they set up huge farms with high processing capability, and the expense for them will be the electricity and the machine cost, and they'll be getting rewards from it. So similar to that also Ethereum work. So there were a lot of discussions that happened that this is something against the nature, like against the ecology and all, because there a lot of computation was happening. It was all because the consensus mechanism that was in place was proof of work. Now, moving on, when we speak about two blockchain here, I'll detail Ethereum in the next slide, but just for you to understand, after Ethereum, like there were a lot of blockchains that developed during this course of time. Okay, there were different blockchain which came into existence. Then I would speak here of Bitcoin, Ethereum, and the third one called Hyperledger. So I'm not detailing a lot of blockchain because this session won't be enough to detail about the different blockchains that is existing. So apart from Ethereum, the next one which came was a private blockchain, a private permission blockchain, which was hosted under the umbrella called Hyperledger. Hyperledger is not a blockchain, but it's an umbrella of projects which basically has different blockchains hosted. Like we will see it in detail. In this case, it's a private and permission blockchain. So the problems with the public blockchain is all the data is public and everyone is having access to it. Now imagine a situation where two or three companies want to use a blockchain, a trading application, and the seller does not want the other person to know the rate of what he has sold it to the first person. So if there is a person A and person B, I sold mangoes at a rate of $10 to person A. Now I want to sell it at $12 to person B. I need the system to be permission. I need it to be private. I need to have private transactions. Sorry, that's basically about the Hyperledger. So that's a permission one, which is highly different from it. And the consensus mechanism that is in place in Hyperledger is not proof of work. In fact, there are different consensus mechanisms which can be plugged to Hyperledger. Do I have any questions here? Okay, I think it's much clearer now. Please let me know if you find any difficulty in understanding. So it's good to interact and move on. That's the reason why I'm asking. Okay, now as I told you in the previous slide, I'll be explaining about Ethereum. This is a photo of Vitalik Buterin. Basically, he's the one. He was a follower about Bitcoin, and that's when actually the revolution of blockchain or the acceptance of blockchain into the technology domain started with Ethereum. Why? The reason is because there came the concept of smart contract. Okay, so smart contracts, like what is smart contract? Now, how is it different? Like why should we call it as a smart contract? So smart contract is nothing other than the if this then that logic. Like most of you from a technology background, or even if you're not from a technology background, how the system that works is by programming, and what programming essentially does is if this then that. That's the most common logic that we face, right? The same thing instead in Bitcoin, where we were sending a Bitcoin from one address to the other address, you make a code. Like when I said, when we are communicating with a particular address, instead of that, on that address part, if you have a smart contract, if you have a code that can be executed, imagine there are like 2 or 3 functions that you can call and that can be executed. That's where the code comes. So how is it different from an existing software system? This code is secured by means of cryptography or secured by means of blockchain. So anything that get executed is permanently stored. There is immutable records of data. So the revolution of blockchain started when the Ethereum came into picture, like when the smart contract feature really came into picture. That's where blockchain developers started to evolve. They started writing smart contract realizing applications, and whatever applications were realized using the smart contracts on Ethereum are called DApps or dApps. Like people pronounce it both ways. So decentralized applications, that's all about. The thing is, I might be communicating with, as I told you, there are different nodes in the network. I might be communicating with a node, and the other person also might be communicating with another node, but it communicates to a particular contract, and everyone has a single point of view. Like there are no different point of views. Like everyone comes into single agreement. If I write, say for example, if I have a function, when we show the hands-on, I'll be basically showing you. So if I have a function which basically writes a word, like if I write an hello world program, which basically sets a word like my name, Naushad. And if all the people calls the contract and checks for my name, they're going to get Naushad. But they may be communicating with different nodes. But even if they're communicating with different nodes, similar to how they were checking for balances of people in the previous example, they're communicating with a particular address where this code runs in a secure environment called Ethereum virtual machine. Okay, so the example is if let's take a real world example. Okay, if I have another person here, so if Smita wanted to buy a phone from me, the smart contract is such that the ownership of the phone will be changed if Smita pays me the amount that I have said. Now the amount might be 10 bitcoins, or if it is an ether, Ethereum, 10 ether. Now if Smita, when the Smita transfers 10 ether to my account, by legally or by contract, the phone is in her ownership. Okay, now it's up to me, I have to ship it, but legally or by means the ownership has been transferred. So this is the beauty of blockchain. Like with Ethereum, the revolution of blockchain began. Now, how are the DApps different from apps? I was telling you that DApps can be communicating with different nodes, but in fact, all these nodes are of one network. All of them are communicating with a particular smart contract, with a particular address to a common source of truth, right? So when it comes to the apps, basically, the present day apps are like you may be following different architecture like microservices or the horizontal vertical type of architecture. You will be communicating, which is basically hosted in a cloud, and when this goes down, the entire application goes down, right? That's how the present one works. But in this case, even if this node goes down, even if this node goes down, until and unless there is a single node, the system does not go down. That's the beauty of DApps. Okay, this is how we develop on Ethereum. So the image that we have shown on the right side is an example of how we will be developing on Ethereum. So as you can see, there is a DApp instance 1 and DApp instance 2. There are two nodes here. So all the nodes have different blocks here, which are communicating by means of protocol they are. And we have on the browser, we have our application called the DApp, which we basically, very simply, I could say that we can develop it on HTML, JavaScript. You're free to develop it on Angular or React or any front-end technologies that you want to use. Now, you use Web3.js. Web3.js is a well-known, famous API for communicating with the Ethereum blockchain. There are different APIs as well. Apart from Web3.js, there's called Ethers.js. So we'll come to Ethers.js as well when we do the hands-on. So, and it's all about the web server. So you basically make RPC calls to Ethereum. So I think it's more clear here, right? So even if this node goes down, like, if the DApp, if it has particularly configured to communicate with this node goes down, this might be an issue. But if there are different nodes here, then we communicate with it. If some nodes also goes down, it's not a big issue. Okay, so that's exactly how the DApps are different from the particular application. But what is not shown here is there will be a wallet which comes into the picture, because you basically want to sign every transaction with a private key. Now it's up to you how you'll be storing the wallet. Like on the browser, you have an online wallet called MetaMask when it is Ethereum. And you can also have desktop application which comes with an inbuilt wallet like Mist, basically to make communication. The whole concept is you need to own a private key which has to be stored. If you're architecting a modern application, you can even use the key store facilities of the cloud where you can store this, and when a person communicates, it's basically going to sign the transactions. It's just a little against the technology that, if you are going to keep the wallet in the cloud, that's not a right practice. But for enterprise application, some kind of things are also seen. Okay, so that's how the DApps are different from applications. Moving on, if there's no doubt. Okay, so coming to here, like the Hyperledger, I told you we have seen Bitcoin and Ethereum. Now, when Ethereum came into picture, the problem was it was a public blockchain. As I previously mentioned, there can be two different sellers, and the buyer wanted to mask the amount that he is actually selling to one person with the other one. So at this time, major companies in the world like IBM, Intel, Huawei, like a lot of different companies came under an open source, like under the Linux Foundation, calling Hyperledger. So Hyperledger is something, okay, it basically has different blockchain development happening under the Hyperledger umbrella. It's not a company, it's not a cryptocurrency. Hyperledger is not a blockchain, of course, it's an umbrella, but there's no particular coin as well in Hyperledger. So there are different frameworks or different blockchains on Hyperledger if you go to the website, but the prominent ones are Hyperledger Fabric. Basically, the most used enterprise grade application blockchain is Hyperledger Fabric. Then the other one that we have is Hyperledger Sawtooth, and the other one is Hyperledger Indy. I'll tell you, like, if you are going to develop most of your use cases on a permission system, Hyperledger Fabric will be the best suited one. Here, the consensus mechanism is not proof of work. Essentially, you are free to plug other consensus mechanism as well. Now we are like previously they came with a development consensus called Solo, then switched into Zookeeper, like Apache Kafka, and then right now I think Raft is the latest one which is being used by Hyperledger Fabric. Hyperledger Fabric, like you can realize different use cases on Hyperledger Fabric, but there is a blockchain called Hyperledger Sawtooth. Now, if you want to visualize, if you wanted to realize a supply chain scenario, Hyperledger Sawtooth is a blockchain which is ready made to fit into such a scenario. So that's about the Hyperledger Sawtooth. So when you wanted like farm to table, or when you wanted a complete audit history of something that you are buying, okay, if you're buying a meat, if you're buying a fish, and you wanted to know at what date it has been caught, and all those kind of details, it has to be coming from a single source of truth secured by means of technology. That's where Hyperledger Sawtooth comes into picture. So we'll see a very short video from the Hyperledger Sawtooth itself so that you get a better picture. I'll just play this.
If Rohan is ready, fine.
Meet Rich. He owns a popular seafood restaurant.
Was there any questions? I think I heard something. No worries. Okay, I'll play this.
In Boston, Massachusetts. Rich strives to serve only the freshest, highest quality fish to his patrons, but he often has difficulty knowing exactly where it was caught, how it got to his restaurant, or if it's even the right species of fish. From ocean to table, the fish supply chain is difficult to track and usually follows this pattern. The fish is caught by a commercial fisherman in the ocean. The fisherman then sells the fish to a market, processor, or broker. A distributor then transports the fish to a restaurant or grocery store for a consumer to purchase. Rich typically only buys from one or two fish distributors that he has built a foundation of trust and personal history with. He'd like to expand his menu by adding some different kinds of seafood from other distributors, but he worries about integrity, and for good reason. He recently read a study by Oceana which showed that 33% of fish purchased from retail outlets is incorrectly labeled, and that illegal fishing represents losses between $10 to $23 billion worldwide. Rich knows that mislabeled and illegally sourced fish could hurt his customers, his restaurant's reputation, and the environment of our planet. Fortunately for Rich and others in the seafood industry, Sawtooth Lake blockchain technology can provide an immutable record of the provenance and lineage of various goods, like fish. In combination with Internet of Things enabled sensors, Sawtooth Lake can manage the ownership and journey of fish from ocean to table. Sensors can be attached to fish the moment they are harvested, immediately and continuously recording data, such as the location and temperature of the fish. Now, Rich can validate when and where his fish was caught and that it was stored properly on ice while it was transported. The Sawtooth Lake platform can also manage the chain of custody of fish, enabling ownership to be transferred and traded on the blockchain according to smart contracts. With Sawtooth Lake as a traceability blockchain, Rich can easily see which fishermen meet his quality standards and feels comfortable doing business with new tradesmen. Serves up a new special to a cherished customer, he can confidently and accurately assure her it's the type of fish she ordered, it was stored at safe temperatures, when and where it was caught, how long it took to get to her plate, and the fish's name. Just kidding. Sawtooth Lake blockchain technology can be used for a wide variety of applications, from capital markets to international trade. The Internet of Things ties the physical world to the digital world, with Sawtooth Lake recording the generated data in a way that all parties can trust its accuracy and completeness. This is extremely useful for tracking perishable goods, like fish. These sensors can track many key parameters such as location, temperature, humidity, motion, shock, and tilt. This technology could be added to any package or sensitive good you're entrusting to other parties. The blockchain will ensure the data is secure and tamper-proof, so that you know what you're getting and that you get what you pay for. Sawtooth Lake creates a digital platform enabling physical traceability in a trustless world.
Okay, so I think the video was all about catching a fish and having all the details logged on blockchain, and the customer or the end person will be having a complete history of records of how it was caught. So that's where the hyperledger sawtooth is. So the whole point was hyperledger sawtooth is something that is intended or designed specifically to address the supply chain scenarios. Okay, wherein if you have another use cases or if you wanted to use a blockchain framework directly, it's better to go with the hyperledger fabric. Okay, now moving on to Hyperledger Indy. Hyperledger Indy is a digital identity blockchain. So I'm not sure if you know about Sovereign Foundation and all. So Sovereign Foundation is something that has come across a different kind of people has come to give digital identity to the people. So we are living in a world of different identities. Like that you are going to different websites, you're going to Facebook, you're going to Google, you are going to different websites, you keep on remembering your username and password, right? So the digital identity which is going to evolve is actually going to replace this. It's going to provide you with a wallet on your phone basically, and you are getting everything as a verifiable credential on your phone. So it's a matter of just imagine like you can log into a platform just by scanning a QR code which basically requests for particular data, and you present it, and if when you present it, if it's the right data, you get access to it. So that's the place where the Hyperledger Indy or the new digital identity is evolving. So the problem with the present identities is that if it is Facebook or Google or any other website, your data is not in your hands. It's being kept with the people, or it's kept with the technology providers. So the true democracy does not exist there, right? So you have to own your data. That's where the Hyperledger Indy basically says that you basically have to own your data. And the long vision or how it's being possible is like there are very fascinating technologies like zero knowledge proofs. Now the good thing with zero knowledge proof is, let us take an illustrative scenario. Okay, now when you go to the bar, you have to prove that you are above say 21 years of age or 18 years of age to buy a bottle of beer, right? So right now what you do does is when they ask you, you are providing your vehicle license or you are providing your other details, which basically has every detail of yours: name, date of birth, address, everything. Why do you really want to show all this kind of information to prove that you are above a particular age, right? That's not really required. Now, so that's where the Hyperledger Indy or the digital identity concept of zero knowledge proofs come into picture. Now, with zero knowledge proof, you may be thinking that, okay, I can just use date of birth to tell him that, okay, I'm above the age of years. With zero knowledge proofs, you don't even need to show that it's the particular date of birth. Instead, technologically, if the request is whether the person is above 21 years of age, the technology at the background checks if it's more than 21 years of age and gives the assurance or gives the verification that just a means of, just imagine like a tick mark which says that the person is above the particular age and he is able to get it. So that's where the digital identity is evolving. Digital passports are evolving. We are yet to see the full potential of how Hyperledger Indy can evolve. So we are moving to a world where you have verifiable credentials. So gone are the days, like your days will be gone where you won't be saving anything on your wallet. You won't be saving your license. You won't be saving your other card on your wallet. Instead, all those kind of details will be saved on your wallet on the phone. It's a digitally verifiable credentials. And you authorize, and whenever you give permission, only those data would be shared. So that's where the digital identity world of Hyperledger India is evolving. A lot of works happening, and there is a real company in production called Street Cred, which is actually realizing it right now. I think they got some grant and they have changed the company name, but there are a lot of great initiatives happening around the Hyperledger Indy world, and we will be soon seeing the benefits of it. So it's all beneath, it's all the blockchain technology which is empowering it. So if there is no question, I'll move forward. Like, feel free to ask questions in between when you find difficulty in understanding, please. Okay. Now, the key features of the blockchain, right? So I was telling you that blockchain had certain features like immutability, where data is stored that you cannot corrupt it. So I've tried to put down like almost all kind of things that comes under blockchain's features. So the first one would be a distributed ledger. You know why it's a distributed ledger? Because everyone has a uh, copy of the ledger. If it's a public one, they have every data. If it is a private one, on a need to node basis, and it's all digital, like, there's no paperwork, nothing involved, updated near real time. Why it's near real time is the technologies like Ethereum or Bitcoin, for a transaction or a block to be confirmed, it takes around an average of some 15 to 17 seconds with the proof of work. But Ethereum is changing its consensus from proof of work to proof of stake. We are yet to see how that's going to happen. Like when it happens, it says that it's more real time. So that's why it's near real time, and it's chronological and timestamp. So the block that particularly involved, you have a fixed, you know exactly when it was formed, right? Because it's something ensured by technology. There are blockchain explorers where you can see, and you can go and check the block, and you can say that, say for example, block 1 was formed at 5 days ago at this particular time, mined by this particular address, and all kind of information should be available. Okay, and it's chronological and timestamp, like block 0, block 1, block 2, it exactly goes in the chronological order. It's cryptographically sealed, by the means of hash function, irreversible and auditable, because if you want to change something on blockchain, the hash changes, you need to change the entire block. Operates trustless, like, you don't want to rely on a sender party. You don't need a bank to come and say that, okay, I take care of the trust. It's instead taken care by the technology. Fewer third parties. In many cases, it's no third parties. You do directly. But even third parties right now use blockchain. There are certain instances like crypto. You might have heard about the topic. I have not detailed here about the crypto coins kind of things here. Like I intentionally did it because I wanted you to focus more on the blockchain technology. Now when it comes to cross-border transfer and all, you use a technology called stellar and all. So there are different kinds of coin like Ripple, stellar. You might be familiar with it because they were more tradable. And there are certain third parties at some blockchain technologies who comes into picture. There are a wide variety of blockchain technologies available. We have narrowed down our discussion to the most prominent ones: Ethereum, Bitcoin, and Hyperledger. So according to the different blockchain implementations, there are different kind of few or some third parties which may become. But essentially, at the very bottom, it's all about removing the third party. Now it's about the use cases, like in short, like what we have seen are the features. Now we have a detailed use cases which is coming up as well. Now, if we would narrow down the use cases into four different aspects, like what falls under smart contracts, digital currency, fraud and fraud detection, record keeping, securities. This seems to be the major ones right now which is seeing blockchain adoption, but it's not limited to here. Now again, as a subcategory, when it comes to the smart contract, you'll be seeing like digital rights. So I could give you an example of your property rights. So Telangana government has actually started moving land records onto blockchain. Dubai has in fact implemented the land records on blockchain. So the good thing is, if the one better thing is the middleman pricing will not be high. So blockchain really has the value of for what value the particular building or particular flat or particular property was sold like 2 years ago. And with the technology, this middleman cannot come and put in a very big price. Instead, it's on the technology secured that this particular price it was sold. So according to the market price, you can buy and things, and you always have a digital record. So you don't, the conflict of interest is less. That, if you come to the present system, you go with the paper and some other people claim for it, and it takes a long time to resolve the dispute and all. And that's about the digital right. It's not particular to the land. It can be any asset that you wanted to bring in digital rights onto the blockchain. Gambling, that's where actually a lot of games which has existed on Ethereum, that you might be buying coins by investing ether, and at a particular time there might be a lucky draw, and some one of you might get an amount, and those kind of different gambling games exist on Ethereum. So that's one other use case of smart contracts. Escrow is someone who stands in middle of you, like I can detail it by an example of an freelance kind of thing. You might be knowing the platform called Fiverr. So basically, when you hire someone to do some work, you make the initial payment, it is being kept by Fiverr, right? And when the person does the work and you agree to it, only the fund transfers to the person who has worked. So this all right now is being done by a middleman. Now, when you bring in smart contract, you don't need the fewer or existing platform there. Instead, the escrow can be handled by smart contract. You can put in a locked phase for this particular time to hold the amount, then you can transfer it. So that's about the smart contract part. Then when it comes to securities, also there are different like equities, private markets, debt, crowdfunding, derivatives. So previously and all, like you might be knowing about ICOs. I'll cut short it. Like ICOs are initial coin offerings. Now, when you as a development team, you wanted to previously and all, you wanted to go and present ideas in front of certain people, you wanted to get money funding for it, then do the activity development. Now, the recent trend in 2017, 2018 was rising ICO. So you put the initial coin, you say that from January to December, we are going to run an ICO, and you can actually invest it. You can put either and get tokens as your dividend share. And so for in terms of developers, they are getting money for development at a easy pace, like not going to different people and presenting it, instead writing a white paper. And but in terms of investors, they are investing in something they find value, they are free to choose it. But there have been instances where developers teams, after taking the money, ran away. Like, so you need to really check for when you do such kind of investment whether there are credible members on the advisory board and all. So that's kind of thing. So, and when it comes to digital currency and fraud detection, so digital currency, you have already seen how Bitcoin has been an alternative, how different digital currencies have evolved. And global payments right now, you know that sending money from US to India has to go through different parties. Even if you're sending by means of PayPal, PayPal takes a cut. Then after PayPal takes a cut, then you again, it again takes 2 or 3 4 days even to remit from PayPal to a particular account. And it's like then you again pay taxes and those kind of things come into picture. So you, and the foreign exchange rate also comes. So you might be seeing a USD, when you are sending money in dollars, you may not be getting the right conversion rate, because you are forced to agree to the conversion rate that PayPal says, right? So this kind of intermediaries or intermediary charges exist. So with the kind of digital cryptocurrencies, even if you send to the neighbor or even if you send to a person in US, it's the same, right? It's all by the same technology. And record keeping, since it's an immutable record one, it's basically blockchain is a real use case for record keeping. Supply chain, we have already seen how well it fits in by the fish example. Loyalty programs, like you can reward coins, right? Right now, you might be familiar with the credit card rewards, and also similar to that, or when you go for purchases, you can have a unified coin where you can get rewards, which you can use to pay for other things. You can use for services, utilities, basically. Ownership, proof of identity is something that we have seen. Intellectual property is something which comes again under the digital rights. So these are the use cases in short. Like we have a very big use cases. This is something that came in the Deloitte article. Little more elaborated on the previous one. So most of things are being covered as same only. So apart from it, we have the Internet of Things, IoT. So we have seen in the fish example how IoT can actually work with blockchain. Then when it comes to the insurance domain, insurance is a real use case for blockchain, and chain of custody, asset ownership, workflow management. So smart contract really fits into it. So when I say that we can remove intermediaries, it's actually automating certain processes, right? So in that manner, the workflow management or taking people from A to B steps, instead of, there are a lot of processes in the existing system that can be automated. So you just need to write smart contract. Okay, when this particular person pays this amount of money, you transfer the ownership. So those kind of things. Digital voting. So this is something of great importance that people are talking about. Voting going onto the blockchain domain and regulatory reporting different. So uh, if you look at it, there are a lot of domains where blockchain comes into picture. So when we work on our company, we basically run a litmus test when a client approaches whether he needs blockchain for it. So we basically looks whether there is a need of trust factor comes into picture by technology, whether there are a lot of people coming into the network, whether they all need to agree on a single source of truth. So these are the different points that we would be checking for a use case, and if it is really required, we recommend them to go with the blockchain. So that's the kind of use cases, and these are just samples about it. When you go to a particular domain itself, say for example, if you are going to a healthcare domain, there are again different use cases of healthcare. So digital identity management is one such thing. So I can explain you by means of a patient doctor example. Right now in the hospitals, you go to hospital A, you are not able to take the record from hospital A to hospital B, right? So most of the time what happens is your records reside in a particular hospital and you are not able to take it. So imagine that your record is linked to a digital identity, and everyone has an identity on the platform. So basically, when you wanted to go to another doctor, you can give access to him by means of this technology. So we, in fact, our company has developed a solution on it called Healtherium, basically digital identity and access management for patients, and health supply chain management. You know about the drugs, and also there are a lot of chances that the drugs can be counterfeit drugs that can happen in the market, right? So that's where a blockchain can come and prove that, okay, these are real and original drugs. And for clinical research and all, right now, the clinical research might be accessing your records and you are unaware about it. So that's another area where you can come into picture, you can authorize them, and you can also get payment. You can even bring a coin to get payment for the data that they are accessing for their research work. And insurance, similar to how we told, like financial and all these things, when it is being facilitated by means of a crypto domain, even a possibility of an health currency is also in place. So you can, there are a lot of applications actually. If I start to speak about the use cases and applications, the sessions won't be enough. So I'll just skip it for, but if you have any doubts, or if you wanted to ask about how you want to really fit in, please let me know about the use cases. So this is, and I have used this particular example to illustrate most of the blockchain applications under a single platform. We were saying digital identity is one great application of blockchain. We were saying workflow automation is one great application of blockchain. And we basically verifiable credentials, all those kind of things. So what I have basically done by this slide is try to portray a complete process, okay, a complete process of going through buying a car. Imagine if the government has issued an portal, and you basically have your phone wallet where you hold your digital identity. And if, say, for example, Indian government here or any government would issue your digital identity as a verifiable credential, which can be stored on your phone. Okay. Now, then you basically could go to the government service portal. Like the digital identity portal may be a different one, so you get your digital identity similar to the e-Aadhaar or something that we can say, and you go to the service portal, you log in with this. When you are asked to log in, it will be basically asking you to present your digital identity. So I have just tried to illustrate a picture where you'll be basically scanning it. So that's where you basically have an application, and it will be basically for logging in. It will ask you a QR code. What actually asking the QR code is to present the digital identity you have in order to log into the platform. Now that's where you basically would be scanning your phone. Once you scan the QR code, a notification would come on your phone, would basically ask you, okay, do you want to share your digital identity with a particular website? Then you authorize them. Once you authorize them, you are taken into the login. Your login is successful. Okay. Now, once your login is successful, we are assuming for the right moment that all the actors are on the platform. Like government can do this automation, the car dealer, the bank, and the motor department. Now, you can go to the car dealer, you can either visit the store, or you can go to the online website of the car dealer. You can choose your car and request for a quotation. Now, when you request for a quotation, it is basically again going to ask you a QR code, asking you to present the digital identity. So that's where you basically would present your digital identity, you scan it, and you get the car quotation. Now, along with the digital identity, you also have another credential, which is a car quotation. Okay. So this car quotation can be presented at a later stage. Now, imagine that you got the car quotation. Now you want to apply for a bank loan. Right now, you might be going through a lot of paperwork, walking to the bank or the representative visiting you, asking for your CIBIL score and a lot kind of things, credit score and all. Instead of that, imagine you have the credit score on your wallet on the phone, you have your car quotation received, and you basically would share it to the bank, again scanning a QR code. Now the bank person would come in middle in the picture, and he would basically check whether you have presented all these things and your CIBIL score is well good for a loan. You can even automate that. Then you get a loan approved receipt. Again, this is a verifiable credential on your phone. So now when you have the loan approved receipt, it is basically saying that when you are making the purchase, the bank is liable to make the payment to the car dealer. Now, the next step that you might have to go is a motor department for the registration. So the motor department would need essential details like, okay, give you the car details, give your digital identity detail, and your loan approved detail, basically. So when you provide them, and the motor department issues your vehicle license. So on your wallet, you have your vehicle license, your loan approved receipt, the car quotation. So imagine like tomorrow you are walking down the road and you are going through a car on the road, and you are stopped by a police officer, instead of showing your driving license, you can just present your QR code to show your digitally attested or verified vehicle license, which can be just shared by scanning. So that's where the world is moving on. That's where the blockchain is actually getting applied on. Okay. So I'll try to illustrate in this. We have done, our company at Tinad has done a project on the similar lines. And I thought this would be really helpful for you to relate on how blockchain can get adopted to the new world. Okay. Now, if you would have a question like, what is the real life implementation that blockchain has really catered and you can point out? So in that scenario, I can direct you to the example of Walmart. Walmart is a bigger supermarket chain, right? So that's like Walmart faced a problem like when an outbreak of a foodborne disease was reported, it took them really days, like 7 days, to track the origin of the food, and it caused a lot of problems. Like if the outbreak was from a particular mango, just for example, and they would have to, right now when such a report comes, they'll have to abandon all the mangoes because they are not sure from which farmer or from which particular supplier they have got the mango, right? So it actually affects the entire process or the efficiency of the process. Yeah. Okay. So now basically what they use the blockchain, Walmart together with IBM use the Hyperledger fabric, and in production they implemented the tracing of mangoes, which went from 7 days to 2.2 seconds initially. So this is where they piloted and they really found the blockchain is useful. And right now Walmart traces over 25 products from five different suppliers using the Hyperledger fabric. Okay. So this is basically a real life implementation of how blockchain has been adopted, just for your reference. Okay. I think now we are enough with the talk and we'll have to go for a demo. So before that, let me know if you have any questions till now. Okay. I can't see anyone. I'm not. If there is no question, then it can be two responses. One thing is either you understood everything, or the other way is like it was full of something that you couldn't understand. It finds me really difficult to carry on like if you're not able to understand. So that's why.
I know, shall I ask one doubt?
Sure.
Uh, okay, actually, I was imagining one use case like suppose we are building a news portal system. Nowadays, we are hearing like a lot of fake news are coming, and it may be days after recognizing like it's a fault information or something. Okay, suppose if in a scenario like that, suppose if we are building a group of journalists, as you showed the example of accountants, instead of if we are making a group of journalists and imagining we are verifying a news, or we are building a blockchain system that for identifying or keeping a right track of information by contributing the journalist as a verifier. Suppose in a system like that, suppose if it is possible to use a blockchain system to implement in that.
Exactly. That's a very great question. That's a brilliant question, actually. So that's a real problem that we are facing with the news. Is like news may come and it may have reached 1,000 people and 500 people would recognize that it was a false news. We have seen several instances in the recent scenario as well. And so, as you said, there is a real use case of blockchain. Now, why there should be a real use case of blockchain is because there's a trust factor which is missing, and there are a lot of factors which are involved. So that's a real use case for blockchain. Now, it can be like you can engineer it, like you can design the platform in two ways. Either it's like you can bring in a reputation score for the users. Say, for example, you can set a fixed number of. There is multi-party signature is and feature of blockchain, like I have not included in the slide. So multi-party signature essentially says that anything becomes valid when we set like this particular amount of people signs it. Okay. Now, if there is a news draft before it gets published, you can use a multi-party signature, which basically says that, for example, it can say like 2 of 3 signature. Now, if there are 3 verifiers, it should at least have signature from 2 reputed journalists for this to be an authentic news. So it will get published only when it gets the particular signature. So it's a real use case for blockchain. Yeah, it can be implemented as well. Okay.
Okay.
Great. Cool. So I have the impression that I'm actually getting something. Now I'll move to the online. So Remix is an online
One more
ID.
question.
So I'm going to yeah. Mahbub is having something. I could see it talking.
Am I audible?
Sorry.
Am I audible?
Yeah, you're audible. Yeah, please.
Yeah. No, regarding the storage, okay. How much amount of data can we store? Based on the previous use case,
Mhm.
if it is going to be a journalism, then there may be a huge data for a news, right? Then
Mhm.
how come they're managing the data?
Great. It's again an interesting question, like really good questions. So as I told you, like blockchain, as you said, there are a lot of data that has to be kept on. It depends on the blockchain actually. So if you are using Ethereum, you cannot store bulk amount of data onto it. If you're using Hyperledger Fabric, you can store more data than Ethereum, but again, there is some kind of gap that you're tapping that you might have to face. And when it comes to the data storage, there are actually on-chain storage and off-chain storage. Okay, this is a very good concept actually. And on-chain storage is something you choose for storing the credential data. That's where actually the hash function comes. Okay, now if I have a document containing news, okay, if I would say that a news is a document, just for the sake of argument, let's assume that a news is a document. I can select news to be an off-chain storage, which basically will be stored in a DB apart from blockchain. But the truth of the document can be stored on-chain storage. So what you basically would have to do is similar to how we saw the SHA example. You take the digital signature or you take the hash of the file, you save it on the blockchain. So it's easy to blockchain to save a hash, right? But it is not a really computationally intensive to store and hash. Now the authenticity can be verified like this. So when the news get published, now the technology itself or you yourself can come and check whether someone has manipulated the news by just checking the hash of the file. You stored the hash of the file, which was like DBA, say for example it was the hash, and when you wanted to verify also if it produced DBA, which means there was no changes that happened to the file, which means the authenticity of the file is secured. Okay, so there is on-chain storage and off-chain storage. Now depending on the use case, now if it is for the news use case scenario, we'll be selecting an off-chain storage and bringing in on-chain storage for the truth verification. Am I that clear?
Yeah. Yeah.
Cool. Great. Nice questions actually. So this is actually, before I move on, this is the Remix older version. Okay, I was very fond of this version because it was very easy to operate. But right now, Remix has moved to a new interface. So most of you, when you look for Remix ID, Remix is an Ethereum ID. I'm going to show an example by means of Ethereum. So most of you, when you search for Google for Remix ID, it will be taking you to a new interface. But I'm so fan of the old one. So whenever I load it, it comes into the previous one. So just for your note, I'll switch to new interface because that would be one which will be coming to you. And whenever you open it, I told you that there is a wallet that you need basically with you, basically whenever you wanted to sign a transaction. So one such wallet which is incorporated onto the browser is called MetaMask, the folks that you see here. So you see this is the MetaMask wallet and I'm connected to the main Ethereum network. And I have different networks here. One is Ethereum network where there is real ether which is needed to make a transaction. I can send either from one person to other. There are different test network as well, Robston, Coven, Ring by Go early as well. So these are the test network which are hosted by the community. So whenever you are making an application, you basically develop an application and run it on any of the test network. I personally prefer Ring by test network because the transaction time is comparatively less. And these are the different test networks available. You are free to host your own blockchain. So if you are hosting a blockchain on your own, you can use a client called Get and all. So when you host, it's normally all the blockchain by default runs at localhost 8545. So you can connect to that particular network as well. So the wallet is in fact capable to be plugged into different blockchain networks. And when you have say for example, I have a custom RPC. I have deployed my blockchain somewhere else and I have an URL, an HTTP. In that case, I can just give the network name and RPC or like HTTP, blah, blah, blah. Those kind of informations. These are not really required at this point. So this is the online wallet which can be added onto browser. It's really easy to add. You just need to browse and add MetaMask. For our demo, MetaMask is not really required. If you wanted to communicate, if you want to deploy the contract and on any of this network, you need MetaMask, and you need really this as well. So when I select the main network, okay, I would go back. Okay, I have 0eth. I don't have any money on the real Ethereum network, but when I switch to ring by test network, I have it's basically asking me to reload because Web3 is injected here, so nothing to confuse basically. So if I would look, I have 4.5, which is test ethers, which are not really ethers. And I have called different functionalities. I've been experimenting as part of my work, and that's where it comes. So it's just an online wallet just for information, and it is secured by 12 words mnemonic private key as well. Okay, enough with MetaMask, just for information only. Now we are coming to the Remix Ethereum version. And if I wanted to, I'll write a simple smart contract. So when I have this folder here where basically I would be writing my smart contract, I can use two programming languages. One is Solidity, the other one is Viper. And when I write a programming language, then I can actually compile it. We have a Solidity compiler here. I can select the compiler version and all. Then I can deploy it. That's where I can select the environment and the account that I want to deploy. And this kind of informations are not really required at this particular point of time. So basically, I would be creating a new file. So when I create a new file, I put that demo.sol. I'm going to write a smart contract on Solidity. So Solidity is the language that we write smart contract on Ethereum. You can use Viper, which is another different programming language. Now, when demo.sol, I'll be basically putting it like pragma Solidity, and I would have to say the version of the compiler that I would like to use. Okay, so I put 0.5.0. Now, when I do this, I need to ensure that, okay, I'm sticking onto the particular compiler version. You see here, I can select 0.5.0 just to ensure that, you know, it's like Python deep, Python 2, Python 3, different kind of thing. So I have pragma Solidity, which I initially declared it. Now, why is it not? Okay. Now I'll start my contract with contract, and I'm going to name it Hello World. Okay, so if there is, like, I have put it now auto compile version, so that's the reason why, you know, every time I'm getting an like if something is going wrong, I'm getting an error or things like that. So that's basically contract Hello World. Now I would define a string basically. Okay, this is the storage that I want to store, string of my world. Okay, so I have said string word. If there is any error, it appears here. So I have declared or initialized a string called word. Now I would have two functions. One is function as say word. For the say word, I'll be passing a parameter basically. So I want it to be a string, and I'll create an error and show you how to solve it. So basically on the string, I'll be passing my new word, string and new word. So when I declare the function, it's basically going to tell that you have not specified any visibility. So you can actually say the function should be public. Public is something that, you know, we are dealing with a public blockchain. So whether this function needs to be publicly visible, that's where you can mention public. If you mention private, it may not be visible to others, or it may not be directly able to call, but it can be an internal function. So I mentioned it public. Still, it's going to give me an error because this string, previously with the 0.4.0 versions, we could directly say that a string is passed as an argument. But now with the new versions, you have to specifically mention whether you are using a memory or a storage. The difference between a memory and a storage is something that is permanent. Memory is something that you're using bounded to a function. I think that's the right word to explain. So I would say that string memory new word. Now it say that you are using an argument which is not used. It's just a warning, but it will soon go. Now what I'm going to say that, okay, my word is going to be the new word that I'm passing. Okay, cool. So we don't have any errors now. So this is like say word. Now I want a function basically to get back this word. I need to read it. Now I write a function to write it. Now I'm going to use a function to read this. So function read word. I'm not going to pass any argument basically here. I'll just initialize here. Again, the question comes, do we want to mention it as visibility? It's going to be public. Okay. Now I can say that this function is going to returns a string. Again, it would be saying me that I have to mention it as memory. Okay. Now I need to say that return. It's a very simple program for you to get hands on. So, okay. So it's like state mutability has been constant public return. So I can mention that it's basically not writing any, it's not making any changes. Like when I call this function, it's not going to make any changes to the blockchain. So I can say that it's a view function. That's what it was saying, that, you know, before it was constant with 0.4.0, with 0.5.0, it has turned into a word called view, which is not going to alter the state of blockchain, just only going to read. When you are going to write, it's going to create a new block. Okay. So that's about save word and read word. So I think we are clear here. So this is a very simple program, a hello world that I have done. Now, when it comes to the compiling part, like I use the compiler 0.5.0 and auto by enable optimization and all, like don't need to bother this kind of things right now. And on the environment side, if you wanted to test only on the browser network, you can use JavaScript virtual machine. Okay, it gets executed here. You don't need MetaMask. But if you want this to be deployed or want to experiment on another network, you can use injected Web3. This is where you use when you have something like MetaMask, because this MetaMask will inject a Web3 inside, and you can, whichever network you have communicated, you can deploy to there. So that's when you use injected Web3. Now, if you have a network, you have set up your own, and you want to communicate with that particular one, you have to basically use Web3 provider. Okay, but for the illustration of this demo, I'll be basically doing it on the browser environment only. So I'll use JavaScript. So JavaScript virtual machine. When I select the account, I need to ensure the account with a balance has to be selected. Okay, 0 Ether is here, so that's not something going to, I need this, since it is a virtual machine, it's giving me accounts with either fake ethers, actually free ethers for testing purpose. So I select something with a 0 Ether. Gas limit and value, I don't want to enter into that complexity right now. Just imagine that when a transaction has to happen, that I told you, like when the person was sending 2 Bitcoin, he actually sent in the beginning like 2.1, right? So that 0.1 is something that is required to satisfy the gas, which is obtained by the miner. So now I'm going to deploy it. So I select the contract, the hello world, basically the one here. And if I go to deploy it, I'm going to see that it's deployed. Success one. So deployed contract here. Now I would detail it here. Now I can see the two functions here. If I read word right now, it's going to bring nothing because word has not been initialized with any string. I can set a new word, like I'm going to put my name. I'm going to save the word. Now I have saved the word. It has actually created an input transaction, created a block. And now if I'm going to read the word, it's going to bring the value. So this is a very simple hello world example on Remix IDE, like using Ethereum. So it's very simple for you to start on how to do yourself on Ethereum. And apart from this, this is something on the IDE levels. And this is, if you want to use a Node.js kind of a client, I have basically written an article. You can write hello world at this JS. That would be enough, or you can mention my name if something such as to come. So this is an article that I have written on Medium, where you can use Ethers.js if you are someone who knows about using JavaScript and Node.js, directly npm initting and saving 2 files basically, and you can communicate with it. So when you communicate with it right now, the private key part, valid part was all taken care by the virtual environment. Similar to that, I have created a Solidity file here. This was written a year ago, so that's why it was 0.4.18. And this is right now deploying into ring by test network. So I have shown steps of how you can load your Ether wallet. Basically, initially when you start your network, you will be having 0 when you initially. So I have shown here steps of, they basically, in order not to spam the network, they have bring in the concept like making a tweet or sending on Facebook, then sharing the URL for getting it. So then you basically get loaded with ring by test ethers. This is the previous version which we initially saw. Now, when you deploy it, there is something called the Etherscan Block Explorer. So that's where you can see the all the details, like Etherscan. Once you see Etherscan, you'll have a better idea. So that's fine. There are all versions of Etherscan. This is on the main net. If you want ring by, there is Etherscan ring by. So you see the last block that has mined right now is of this particular one, about 20 seconds ago. Now the transactions also, you can see latest transaction which has been included in the block. And if you look at evaluate the block, you'll be seeing that, okay, the block height is particular, this one, and it happened this particular time. There are 146 transaction and internal transactions. So internal transaction is like if there were more transactions that are included inside a function. So if I go for seeing the 146 transaction, I can see this is the transaction hash. Every transaction comes with a particular hash. It is a unique one. It will not be coming again, no redundancy. And it is sent from this particular address to this particular address. And an amount of 0.09 ether was spent for the transaction. It is the equivalent USD value, and the fee, the gas value, was 0.12. So all the details that you can see can be seen here. So Etherscan is one such explorer that you can go and visualize yourself. So for whoever wants to try out yourself, you can use the Hello World Ethos.js. This article, like those details that you can see when you deploy a contract. The one I used is ring by test network, similar to Etherscan mainnet. You have Etherscan ring by, you can search it. And once it is done, you have your ABI. So ABI is something called application binary interface. So I think like, okay, I think this thing is interfering at work. Okay, so on the when you compile your contract, basically you can see here you have ABI. It's an application binary interface. So you need this ABI when you are communicating from a client. Okay, ABI is JSON basically of saying about what all are the functions present here. So then you can, anyone who's free, you can try out the Hello World Ethos.js as well. And I think since we are running short of time, that if I include that, it might go beyond. So that's about the enough talk. And any questions, please?
Hi, Naushad.
Yeah.
Just to know that uh, for the blockchain-based development, we may need multiple servers and hosting complications, right? So, do we have any pass system based on the blockchain manipulation, or
Great,
any
great.
service available like that?
Yes, exactly. So right now, okay, Ethereum and all is like public blockchains. Now, when you would come to here, like I'll just, you asking whether there's a platform as a service for blockchain, right?
Yeah.
Yeah, so Quorum is a different, Quorum is similar to blockchain, Ethereum only, but it is something that is being used by enterprises. Like it's like there is a private transaction as well available. Pass for Quorum is available on Azure, actually. So on the Azure, there is actually PaaS service for Quorum, which is similar to Ethereum. And again, there is PaaS service for Hyperledger Fabric on Microsoft Azure, also on AWS, also on Oracle Cloud, and also on Alibaba Cloud. So there are a lot of, like, I will just show you Quorum. Quorum, if I would show you, you might be finding some time difficult because it's a new term. Hyperledger Fabric is on Azure actually. On AWS also it's there. There are courses as well. So it's being set up by a Kubernetes service. There are a lot of nodes which is coming into Hyperledger. So you have PaaS actually. The answer is you have PaaS service for deploying Hyperledger Fabric, Quorum, or different other blockchain as well. R3 Coda is one such one. So Azure is providing it, AWS is providing it, IBM Cloud is providing it, Alibaba Cloud is providing it, and Oracle Cloud is also providing it. Does that answer it?
Yeah, fine.
Yeah.
Thanks.
Sure. Any more questions, folks?
Hi, Naushad.
Hi, Harish.
Hi. So my question is, for people from non-development background, is there scope in the blockchain domain to start with a career?
Exactly. Yes. So this is something that is being revolutionary, right? So when you look at the technology domain itself, you need not have a technology background to say that whether an application really requires blockchain to be used, right? So there is always like right now I work as a senior blockchain consultant with the company. When it comes to a consultant activity, you are not. It's good to have you need to know the basics on how blockchain works and what are the blockchain capabilities basically, but it need not really require you to be a techie guy. You just wanted to look at seeing a problem statement and analyzing if basically blockchain is really required here. And apart different domains, like if you are specific to this is one area, like you can be a blockchain consultant yourself if you would understand how the technology really works. Another area is specific to the domain. Let us say for example healthcare. Now the problem right now what the industry is facing is that there are no people to bridge both. Like the techie guys are very sure about how blockchain works and all, but when it comes to real life implementation, the techie guys doesn't know what exactly are the problems being faced in the particular domain. Say for example healthcare. So you can be an SME wherein you can basically SMEs are more seen in the part of fintech domains basically, but I'm taking an example of healthcare. When it comes to an healthcare application, since we were doing it as one of our activity, there were a lot of jargons or there were a lot of problems that we were facing when we as techie guys were trying to understand the healthcare domain. Now when a person who has expertise on the healthcare domain, if he could understand the blockchain, he can actually be a facilitator, or he can actually be on a domain or an SME analyst of blockchain, which can basically bridge the gap and take blockchain into new dimensions. It applies in all domains, especially on the fintech domain. Does that answer?
Okay, good to know. Thank you.
Yeah.
Is it possible to make this recording of the meeting available to the participants?
Sure, sure. I think normally if you are a member of the Prathidhwani Tech Forum, they would upload it as a link. That's what I think. Or maybe if required, we'll email the recording as well.
Okay, thank you.
Okay.
Thank you, Naushad.
Sure. We'll wait for 2 to 3 minutes more to see if there's any more questions. Yeah. Hi, Krishna.
One question regarding the airline domain. There will be a ticketing section on that. You have mentioned that there is a application of blockchain in that. So can you elaborate on that?
Yes, sure. So right now, airline domain is a very complicated domain because, as you know, that the service providers, the airline companies, there are a lot of brokers coming into picture, and there are a lot of different loyalty programs coming into picture. It's a very huge and complicated domain when it comes to airline domain, right? Now ticketing is a very important aspect, which is right now, you know that you might be going to a travel agency, the price will be different from if you're taking from another travel agency. And if you are specifically going to particular sites like Make My Trip or those kind of service providers, you would be again finding a better offer. And there is also loyalty points coming in. So if you might have made purchases on Flipkart, and sometimes they reward you with a 50% off that can be redeemed on an airline ticketing purpose. So loyalty, rewards point, ticketing system, removing the intermediaries, broker system, it's a great application for the airline domain. So when it comes to ticketing especially, right now, instead of bringing in a lot of brokers, if it can be directly between the airline agency and the customers on a single window, like bringing in all the airline agency onto a platform, like whoever is ready to join, and the ticketing can be given for a fair price without a lot of intermediaries making a price. Blockchain is a real use case for it. And another one, the whole solution comes when you basically have the ticketing different airline company as participants of the network. You have people who want to buy the tickets also coming onto the network, basically on the web platform, and everyone gets a fair charge of whatever comes. And there are a lot of intermediaries which can be removed. And at times complexities also arise that when you are about to book, you might lose the ticket, and also those kind of discrepancies or problems can be avoided. So that's one area. And another area is the loyalty or reward management, which has a huge scope with blockchain right now. Because if you bring right now, what happens is, even if you get Flipkart, like if you are a member of Flipkart who has this one, you don't want to travel right now, but you are given a coupon which will expire in 15 days, right? Now you are not able to transfer it, you are not able to give it to someone, or you're not going to extend it. When it comes to a single platform, it can be architected that this can be used at any point of time, like those rewards can be claimed. It will be really helpful. So that's another aspect. And moving on to the higher vision of airline industry, that's where the digital passports come into picture. So right now, a lot of fake things happen. Or even if you take the recent COVID scenario, our initial outbreak cost was from the persons who traveled from Italy, right? Now it is said that, we are not sure about how true it is. Yeah, it's said that basically they travel from Italy to Qatar, then from Qatar to Cochin International Airport. Now they bypassed the rule saying that they traveled from Qatar, because even though they were traveling by transit, they mentioned they traveled by Qatar and they could go out. Imagine if it was automated by means of blockchain. If they had the digital passports, there is no need of the person going and saying that I travel from Italy. Instead, on the immigration officer can basically look at his digital passport and see he's actually traveling from Italy and he has come through Qatar. So that's a higher vision of where blockchain can really apply. So airline industry has a huge demand, or like a huge potential for the application of blockchain. Is that clear?
Yeah, thank you.
Yeah.
Thank you, Nausha.
Sure.
Nausha, one more question, that the passenger details and also store those information, like there are some GDPR compliances and how blockchain can handle that.
Great, a really great question. So that's where the Hyperledger Inti comes into picture, right? So the Hyperledger Inti, the unique blockchain for digital identity, it's something that says about the GDPR compliance. In GDPR compliance, the right of the data should reside with the person, right? So that's exactly what digital identity is saying. So you are liable for your data. So in the previous example where we discussed you getting a vehicle license, a digitally verifiable vehicle license, you are keeping it in your wallet, right? So you own it, no one else own it. And the proof is there on the blockchain only. And I can illustrate it by a better example. Just take the case of Alice. Alice, who graduated from a college called Acme College, Faber College, just for example. This is an always used example, that's why I'm using it. Alice graduated from Faber College, and she gets her credential or the certificate issued as a digital credential on blockchain. Now that credential is saved in her wallet. Now, when she want to apply for a job in a company called Acme Corporation, she would be presenting the digital credential or the certificate that she gets to Acme College. In the present scenario, what really happens is the college or the company would actually appoint a third-party verifier who would check with the university or the college and then come back, which will take time. Instead of it, when it comes to digital identity, where she shares her digital credential or digital certificate with the company, Acme Corporation, it can just check the blockchain whether this is a true credential issued by the particular public address or the particular Faber College, then can be directly validated. So it's really easy. So that's where the digital identity is driving. Now coming to GDPR, GDPR is actually bringing out regulations on you owning the data. Exactly that's happening here. You are owning the data. No one else owns the data. You are given authority to share data. When you scan the QR code for a request, you decide whether you want to share. Before scanning it asks you, hey Alice, you are going to share your credential with a particular address. Are you sure you want to share? Now it's up to you. You can decide you don't want to share. No one takes data on behalf of you. And another important aspect comes to GDPR is the right to be forgotten. So GDPR says that you must be able to delete something, right? So that's where revocation comes into digital identity. You can actually delete your credential. You can actually revoke your credential. So GDPR level or the real implementation of GDPR's vision can be achieved by the digital identity that is being implemented by Hyperledger India. Is that clear?
Yeah. Thank you. Thank you, Naushad, for your explanation.
Sure, always. We have like 5 minutes more left. We'll take a couple of questions, and if there is no questions, then we'll move on. Like
Hello, Naushad.
Hi, Abhin.
I'm pretty new to this technology, and regarding this hyperledger, you show that there are three kind of hyperledger. So each of the hyperledger is sophisticated to the purpose. For example, you mentioned that Indy is for identity management, right?
Yeah, can you speak a little louder, Abhin? I'm finding a little trouble hearing you.
Yeah, actually, I was asking you that you mentioned that different type of hyperledger.
Yeah.
So each of the hyperledger which is sophisticated to the purpose.
Not really. Like, when I said Hyperledger, I'll go back to that slide. When I said Hyperledger Fabric, that was something, with Fabric, you can realize lot of different things. Lot of applications require Hyperledger. For example, the Walmart tracing use case is implemented on Hyperledger Fabric. So Hyperledger Fabric is a blockchain framework, and you can realize a lot of things on it. But when it comes to Hyperledger Sawtooth, it is something that they have designed with the vision of specifically for the supply chain. Similar to that, Hyperledger Indy is something they have designed specifically to address the digital identity. So Fabric can be seen as a master of everything, but Sawtooth can be something that is specifically designed, and Indy is also something that is specifically designed. So I have only labeled these three because these three are the prominent ones. Apart from this, there are different other, like Hyperledger Burrow is there, Hyperledger Iroha is there, something for the mobile app. Then you have different tools available. Like later, right now there is another one which is Hyperledger Besu, Ethereum on Hyperledger actually. So, so the whole answer is like Fabric is something which is master of implementing everything, and you are free to implement even the supply chain on Fabric. But when it comes to Sawtooth, it is something specifically designed for the supply chain.
Yeah. Okay. Yeah, that's the answer. Thank you.
Cool.
And I have one more question.
Sure.
It's regarding a technical background. So we have used, as a demo, we have used Solidarity and Viper. So what are the other programming language which I can make use of?
Okay, great question. So on Ethereum, it's strictly limited to Solidity and Viper. So Solidity is the one which most of the developers use. It's not really hard to get read on Solidity. So if you would Google Solidity, read the docs. It's if you are familiar to C or JavaScript, it's really easy to start with, because there is some kind of limitations that you have to do. Because the reason why such a language has evolved is because there was huge demand for security that has to be taken care. So integer overflow, those kind of issues has to be addressed. In terms of adoption, like I had this in mind when I was designing the documents. But in terms of adoption, previously it was really hard. Like, you had to particularly study Solidity to work on Ethereum. But now when it comes to Hyperledger, you have SDKs which are available in Java, which are available in Go, Node.js, and even Python. So almost all the programming, like there is a huge adoption which is seen on the blockchain. So if you are familiar with any of these particular languages, you are free to experiment Hyperledger. And even if you know about Node, you know about Java or Kotlin, you're free to experiment blockchain like R3 Coda. And when it comes to Ethereum, when you architect the smart contract part only, you have to learn either Solidity or Viper, which is really easy. Like it's not, if you have some technical background, some basics of programming language, it's really easy to catch up. And seeing the major adoption, you see that now almost all the flavors are available to be used with the Hyperledger Fabric. So it simply says the adoption that has come with the industry on blockchain.
Yeah, thank you. So I'm being a Java developer, I'm loyal to Java. So that's what I wanted to know, that how this Java come to the picture while thinking about how Hyperledger Fabric.
Sure. On the Hyperledger Fabric side and also the R3 Coda that I said, you can directly go with the Java. And also on the Solidity side, yes, you are already background from the Java. It's really easy for you to learn Solidity as well.
Yeah, thank you.
Great. So I think we are reaching 1 o'clock right now, just finishing it on time. So if there is no more questions, then I'll move on to the final like thank you slide. It's like as I told you, like I have the email ID here. If there's anything you wish to know or get in touch with, you're free to get in touch, and this is my mobile number as well. um, and I'm available on LinkedIn as well. So just take note of the Medium article Hello World Thursdays if you basically wanted to read more on it, and feel free to clap aside if you find it really worth. And thank you all for bearing me for the last 2 hours. I hope the session was useful. And if there's nothing else left, thank you all once again for being part of this.
Thank you, Naushad. Thank you.
Thank you.
Thank you all.
Thanks, sir.
Thank you, Naushad.
You're always welcome. So
Thanks, Dr.
yeah, I have actually left some of the questions on the private chat. I'll, yeah, so I'll replay them